Hi guys, so for today's lesson we're going to be dealing with reciprocal trigonometric functions. First things first, so trigonometric functions, they were pretty much just cos, sine and tan, and when we graphed them last lesson we saw what they look like as a curve. But today we're now going to be dealing with reciprocal trigonometric functions. So the idea of this word reciprocal is pretty much the flipped version of sine, cos and tan. And we've got to remember that the word reciprocal means the flipped version of a fraction typically. So pretty much we're flipping sine, cos and tan. So obviously sine, cos and tan are all over 1. So if you flip them, the 1 goes up the top. So you get 1 over cos, 1 over sine and 1 over tan. And the specific words for these reciprocal trigonometric functions are secant, or sec for short, which is 1 over cos, cosecant, or cosec for short, which is 1 over sine, and lastly cotangent, or cot for short, which is 1 over tan. You do need to remember these. So the way that I like to remember it is that this one here has like cos in it. Cosec has cos, and that's the one that doesn't go with cos. So I think to myself, it doesn't go with cos, it goes with sine instead. And sec, well, you just got to think to yourself, sec is the one that doesn't have the cos in it, so it's kind of, that goes with your cos. I know it's a little bit weird. And then cot and tan, you just got to remember go together. So they can be a little bit tricky to remember, but it is something that it's really important that you commit to memory. Okay, so when we're graphing these, this is pretty much what we're doing this lesson. We need to be able to graph these reciprocal trigonometric functions. Okay, so we want to use the graphs of sine, cos and tan to help. Okay, so what's the strategy when you're graphing y equals sec theta? Well, the strategy is to remember that sec theta is the same as 1 over cos theta. So when cos theta is equal to 0, suddenly this fraction fails because you can't have 0 on the denominator, you can't divide by 0, so therefore sec becomes undefined. So I'll say that again. When cos of theta is 0, suddenly this fraction fails. You can't do it in a calculator. So therefore we say that sec is undefined at that point. So when is cos of theta equal to 0? So cos of theta is equal to 0 right here, 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 and here. It's all on the x-axis. It's equal to 0, this point here. So at those points, we've got to think to ourselves it's undefined or it's a asymptote. You can't have anything for that point. Okay, so let's use this graph here. Sorry, that should say sec y equals, let's change that now, y equals sec theta. Okay, so at these points where it equals 0, so at 270 it equals 0, so notice out of this 0 point I'm making a asymptote. At this point here it equals 0, so I'm making another asymptote. At here it equals 0, so another asymptote. I'm just looking to see where it hits the x-axis, because that's where it equals 0. So they're my asymptotes for this function sec of theta. Okay, next up, the next strategy is this one here. So when cos of theta equals 1, sec of theta equals 1. So they equal the same thing when it equals 1. Where does cos of theta equal 1? It equals it here, here, and here. So we know that sec theta also equals 1 at those points. So at those points, I'm going to put a red dot because I know I'm using them again. And what happens is, because we've only got points here, I want to draw a red line for sec theta. What happens is, from this point, it goes really close to our asymptote. It makes these kind of U shapes. So here, gets really close to that asymptote, gets really close to that one. And over here, same thing, gets really close. So that's the idea. Now the third part, this last one here, when cos of theta equals -1, sec of theta also equals -1. It's the same sort of idea. So when it equals -1, which is down here in here, sec theta also equals -1. So it uses this point again, uses this point again. And you see these U sort of shapes going down now and getting really close to these asymptotes. And now you can see the graph of sec theta, which is just this red line. If I remove the blue line, you may be able to see it a little bit easier. Sorry, just bear with me. I'll have the blue line completely gone for your notes. And you end up seeing pretty much this line is all over the shot, really. There's a whole heap of different parts to it. But that is the graph of sec theta. Yeah, just a whole heap of little parts everywhere. If you put sec theta into a graphing calculator, like into GeoGebra or something, it's exactly something like this. Okay, so let's move on. Now, sine theta links up with cosec of theta. They're similar, they're just the flipped version of each other. It's the same sort of idea. So the idea is when sine theta is equal to 0, we get asymptotes for cosec. So let's put in our asymptotes. So here it equals 0, so there's an asymptote coming out there. Asymptote for this is 0. Asymptote along the y-axis. Asymptote along here. And asymptote along here for the 360, minus 360, sorry. So you've got all those asymptotes wherever sine theta equals 0. And similarly, when sine theta equals 1 and minus 1, cosec also equals those values. So it also equals 1, also equals 1, also equals minus 1 down here and down here as well. Okay, and you want to again make these sort of U shapes with the asymptotes. So this one down here makes a downwards U. This one up here makes an upwards U. So it's just getting really close to these asymptotes. And you see that sort of graph. Again, let's get rid of the blue line. It looks very similar to the graph we just did previously. It's just they're just these asymptotes and U shapes, etc., just in different positions based on the angle. So very, very similar. So I'll get rid of all those completely for your notes, just so it looks a little bit nicer. But I'm hoping that you're picking up on the idea. Okay, so let's move on. Now, cot is slightly different. There's a few things you got to remember. So the idea is that cot is 1 over tan theta. So when this tan theta is equal to 1, cot of theta is also equal to 1, because 1 over 1 is equal to 1. When it's equal to minus 1, cot theta equals minus 1. So the 1s and minus 1s are the same. When the tan of theta is equal to a 0, cot theta is undefined, similar to to cosec and sec. But this is the new one, guys, down here. When tan theta is undefined, so when it was already undefined, cot theta is actually equal to 0. So let's try to take that one on board. So let's see how we go. So let's do the easy ones first. So when tan of theta is, let's do the asymptotes first. So when it's equal to 0, here, 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 and here, they're going to be asymptotes, because when you're dividing by 0, that's undefined. So let's give that a try. So on my graph, let's put in some new asymptotes. Sorry, I'll just center it a little bit better on my line. There we go, that looks a little bit nicer. Okay, so let's try it. So 0 is here, so new asymptote, I'll put this in red. 1 here for 180 because it equals 0. The y-axis is going to be an asymptote. Asymptote here for cot theta because it equals 0. And over here as well. Okay, so we see our asymptotes. We also want to use our plus and minus 1s, so they're going to be the same. So let's use our red again. So whenever it equals plus or minus 1, so pretty much when it's along this green line here, those dots there, that's when it equals 1. And here's where it equals minus 1, these purple dots again. So let's use those dots. So red dot, red dot. Just going to use each one. Sorry about the messiness. So I'm using those dots still. And the next thing we want to do is where we had our asymptotes. So notice these asymptotes for tan. Where we originally had asymptotes, we now have zeros. This is probably the main one that people forget. Okay, so let's put a red dot for our asymptotes. So we've got a dot there for each of these original asymptotes that were blue. Okay, now we've got lots of points. Okay, so let's now get rid of these brown lines which were kind of getting in the way and making it hard to see what our COT graph looks like. So let's use these red dots. Also the purple ones there. I missed that one and I missed that one. Okay, so you can kind of see these dots kind of having some sort of pattern. So let's put them together. So we've got to use the asymptotes and we've got to use the dots. So it looks very similar to tan theta, but it's pretty much just like going the other way. It's kind of like a mirror image sort of thing. Not really, but close, like, you know what I mean. So you get this sort of snaking shape. That's using the asymptotes and using the dots as well. So they look very similar to each other, this one and this one. They're pretty much just like snaking in the opposite direction. And their asymptotes and their x-intercepts are in different places. It's really important to get them in the right spots. So hopefully this helps you with your graphing of sec, cosec, and cot. Good luck with the questions. Bye.